Welcome back to the Old Iron Lever channel. My name is Bob, and this is the bending brake project. In this segment we're going to look at the construction of the clamp bar, and that's a bar that runs between this clamp arm and this clamp arm. It's drilled to accept the fingers, and you can see the other end of it here. This is another view of it. All right, we got I think two more major pieces to build, and maybe a few odds and ends, but basically we're getting close to the end of the builds here. So the first one that we're going to build, that's about the 10th piece, is this bar right here, which is 1.5 inches this way by 1 inch that way, inch depth, and it keys into those little arms on the side, and there's a bolt that comes in and holds it. And there's the drawing for the bar. It's this one here is going to be 30 and 29/64 long end to end. It's going to have a 750 thousandths ear sticking out, or a cutaway, inside to fit the profile here. And then this will be drilled and tapped, and all the bending fingers will bolt onto this. So anyway, that's what we're going to make. The setup here is in the vise. The vise is trammed in. It's well within 1,000th. I've got, I'm sure you can see if you look real carefully, I've got a machinist jack back here to take some of the weight so it won't tend to vibrate loose in here. I've got this clamp good and tight. I've got a 3/4 inch 4-flute end mill in here. And first thing I'm going to do is just clean up the end. Then I'm going to put the 2-inch indexable end mill in and run as far as I can. We're going to leapfrog again. We're going to do that several times because I'm going to have to do all 4 sides. Then I'm going to cut it to approximate length, and I will use the end mill on the other end to get it nice and square and exactly the right length. It doesn't matter that much if it's off just a tiny bit. There's some play in the system. Anyway, pretty simple piece, but it's going to take a little bit of doing to make it, just because the amount of distance I can reach with the mill. So first things first, we're going to just trim this up a little bit so it's nice and square. This end is pretty square already. The other end we're going to cut off anyway is way off. So way off. I can see light between the end of the piece and my machinist square. So that said, here we go. I better touch off first. Okay, got that right where I want it. Taking a 10,000th cut on it and see if that cleans it up. I did a pretty good job. I'm going to run one more light pass across there just to make sure I'm happy with it. Yeah, it looks real nice. Switch mills out. Now what we're gonna probably have to do here, since this setup is a little loosey-goosey, for lack of a better term, I want to make sure that as we're taking our cut over here, that we're getting approximately the same amount taken off the whole length of the cut. Otherwise, we're going to wind up with, 10 thousandths off here, and 20 thousandths off there, and 40 thousandths off there, and 55 out there, and then we'll wind up with this big wedge, and don't want that. Okay, I'm going to start there at 0. Go as far as I can that way. I need to lower this end. Right at 200 thousandths. Okay, now we're down to about 4 thousandths. There's a little bow in it, but basically that's from there to there is 0. So I'm happy with the way it's laying out here. Okay, I'm going to go ahead and touch off and just take a little bit off. Yeah. I'm going to go handheld for just a minute here. The next operation we have here is to cut this little notch, and if you look right here on the side frames, there's a bar that sits in here. It actually extends wider than this, and this is 3/4 of an inch wide, this groove is, and the bar is actually closer to an inch. So up at the top end here, we're going to have it notched so it comes up over the outside of this. Okay, this is the bar, and this is one end of it that we're gonna notch off, and I kind of made myself a little marker so I remembered which way. And anyway, I've got the quill locked. I got the Z-axis and the X-axis zeroed out on this corner right here. So I should be able to come in on this side here. The slot, or the little rabbit there, would be 168 thousandths wide and 110 deep, and I can take that all in one pass. So bring it out, and we'll set it for 110 deep. Going to be at 110 deep. That is the Z, and we're going to be at 168 on the X. Table's a little loose, so I always have to fudge it a little bit here. Not that it's that critical, because actually the piece that the ends that bolts onto this are they're going to the pivots and everything on them has some play in them, so I got it close. I got a very close fit, But if it has to pull in a few thousandths one way or the other, it's fine. So anyway, we're going to just take this in one pass. I used a couple of 1, 2, 3 blocks and faced off of here against, you know, blocked up against here and a constant distance to the edge. And so this thing, this edge here, even though it's an unfinished edge, should be very parallel to the front of the table. So now I don't have to really change anything. I'm just going to go get myself a little more depth, so I can cover it all with with that mill, and we're going to face this off. And I suspect it'll take about 15 thousandths to clean it up, but we'll find out. And I'm not going to get a full cut here, so when I get to the other end of my travel, which is about yay far, then I'll have to clean everything up, reset it all, respace it from the front edge, check and make sure that the mill is actually hitting it exactly where I want it to. So first thing I'm going to do is bring it in a little bit, and I'm going to just touch it off. I'm going to zero the Y. So that's my touch off point. So I'm going to go ahead and take 15 thousandths. I've got plenty of spare here. This thickness doesn't have to be anything critical at all. So take 15 thousandths off and cut as far as I can, and then I'll take it all apart and reset it. Let's try 20. Let's try 25. See if that gets it. Yeah, that's getting it. Okay, I went ahead and dialed it back in with the dial indicator. So I got to touch off and take another pass here. Let's see, get my quill down where I want it. Okay, now we're going to take that little notch out of here for the rabbet joint. And going to zero the Z first. Now we got to get all reset and come in on the back side and clean it up. Got it all dialed in within the roughness of the piece. We're a couple thousandths one way or the other, and we're basically doing a cosmetic cleanup here. So we're going to touch the Y off. We're getting about as close as I think we can get. Right toward the end, it tends to pick up a little bit there, and I think it's just the way the steel is. But anyway, that's what we're going to go with. Tighten down the clamps and get with it. Okay, that finishes the machining other than drilling the holes on the end. So we'll come back to that in a bit. Well, I'm not crazy about making mistakes, admitting to mistakes, or fixing mistakes. But in this case, I'm just going to have to do it. And I figured I might as well do it on cam. So I was drilling the holes that mount these into the little side frames, like so. And I punched it very carefully, and the drill walked away from where I needed it to be, badly apparently. So rather than drill another one by hand and all that, what I decided to do was clean the holes out real good, screw a bolt in there, clip it off flush, it's Loctited in, and then I'll offset and drill another hole. Well, tried that and the drill walked again. I think the bolt was a little harder than the steel around it, so it walked into the softer steel. So I'm not going to play with that anymore. I extended my ram out. I turned it so it would get over here where I could reach it. And I have this clamp, the angle block and 2 clamps here holding it. I've checked it for vertical and it's all squared away. What I'm going to do is get a mill lined up, and I don't know the size I'm going to use yet. But I'm going to, I left part of the plan out here. Anyway, I'm going to mill a hole down there. I'll have to get a center cutting mill and get it square in, exactly where it needs to be. This new hole will be centered exactly on the where the bolts should be. Then I'm actually going to drill it oversize to be exact. And instead of 3/8, this is going to be 25/64, I think it is. And I'm going to Heli-Coil it because I don't want to try and leave a sliver of metal in there. And I'm not sure exactly how I'm going to get around that, but I may have to do a couple things. I may have to actually drill it quite a bit oversized, plug it, and then drill the plug. But we'll get to that. Right now I need to get a hole in here that is dead center of that bracket, right where it needs to be, and I'm going to use an end mill to do that. Well, this thing is too long, so I had to hang it off the edge of the table. If I can Heli-Coil that for a 3/8 inch Heli-Coil, that takes a 25/64 drill bit. I need to be, that is just a hair over 3/8 of an inch. So if I can get a 3/8 end mill in there, this is the orientation I need to have. Get zeroed in on that. Okay, that is pretty darn close right there, I think. I think that's where I'm going to put my hole in. I'm going to lock this down. Okay, I'm going to just come down and touch this off and see what it looks like. That looks pretty darn good. Okay, there's an inch deep. That'll be plenty. I'm using 3/4 inch bolts, and they don't even go in 3/4. So. That hole should be dead on where we want this thing to be, but let's just double check it. Boy, it looks very, very good. That's just right where we want it. Okay, now we're going to take that out and set up for the Heli-Coil drill. That's the 25/64. It's just what we needed for the tap. Now I'm just sitting here assuming for a moment that everybody's seen Heli-Coils and knows how they work and everything. But in case you haven't, bear with me. I've used a lot of these things over the years. Damaged threads, mostly in Chevy engines and stuff. But so you have a stripped out hole. In this case, it wasn't stripped out, but the principle's the same. And so you drill out the old threads, whatever of it you can get, with an oversized drill bit. And that oversized drill bit, or the kit, comes with a special tap that's going to be it's a 3/8/16 Heli-Coil tap. And what it is it's the same thread pitch as the Heli-Coil is. The Heli-Coil looks like this, and it's because it's a spring basically. It's 16 threads per inch inside and outside, and this is going to be 16 threads per inch, but the diameter is going to be big enough to accommodate this insert. Make sure I can show you that. Yeah. We'll tap this out, clean the hole out real good, and then there's a special tool, like so, that you screw the insert in with. And with a deep hole like this, I don't know if this is the real protocol or not, but I've always stacked up the Heli-Coils. I'd had no problem at all putting 2 of them in, and it just pop in. When you get done, you smack them with a punch, and it breaks off the end of the Heli-Coil right where there's a little notch here, so you have a clean thread all the way through. So, and I've stacked Heli-Coils for years and not had any problem with it. So the next thing we need to do is we'll get this chuck out of our way, and then we'll go ahead and tap that and see how we look. By the way, I don't know how they come anymore, but this is how they used to come. And I lucked out being an older fella and been working on cars since I was about 13 or 12 years old. Years and years and years ago. I mean, back in the middle 60s probably. I started, when I needed a Heli-Coil, something, I would buy a Heli-Coil. Or if I found a good deal on one I might use, standard size, I would go ahead and buy it. They were, I don't know, $8-10 probably for the kit. And so over the years I've accumulated a real nice whole toolbox full of the things. And I went to look at the prices, what they are nowadays, and I don't remember the price, but I do remember being astonished at how much money worth of Heli-Coils I now have in my toolbox. It's hundreds and hundreds of dollars. So anyway, we're going to tap this thing. Now, if it turned out that there's this little sliver of stuff in here and it comes loose, I've Loctite Loctited it in with Loctite Red. But if it turns out that this breaks it loose or something, I have another strategy I've used in the past, is drill the hole even bigger and put a piece of put a pipe plug in there, and then I got a whole lot of surface to work with, and I'm drilling right through the pipe plug. Or you can put a bigger bolt in, as long as you don't have materials with different hardness, you know, this virgin material here and a bolt putting in there to plug the hole. So, you know, there's a way to get around that, but I'm hoping this will hold, and we'll see how it goes. I suppose I could put a tap follower up there, but I don't think it'll help because this has got very little bevel on it. So you just got to eyeball it. I was afraid of that. It's going to pop out of there. That little sliver is coming loose, so we may not be able to get this way. So I'm going to go grab my diamond point chisel. Got a couple of these diamond points. I'm going to use the smaller one. See if I can't take out the edge of that thing, kind of collapse it and dig it out with a pair of needle nose. Hey, it popped right out. Grab a pair of needle nose. Sorry about all the running back and forth, but I almost never think things through, so. Okay. Got it. So there's my I think this will probably work actually, so. It'll take some doing to get the tap started straight, but. The nice thing about it is if there was some threads left from the original hole off to one side there, these will probably, Heli-Coil tap will probably catch them and use them, so we won't have two sets of threads floating around in there. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Got 11 and a half threads in there, more or less. And each of these Heli-Coils has 1, 2, 3, 4, 5, 6, 7. Has about 7 threads. So if I put 2 of them in, I'm going to have one sticking up, and that's really not the way you're supposed to use them. And there is some extra long ones. I don't know if I have any of those in my set here. And let's see what we got. I think these are fine threaded ones, but they look like they are. So anyway, I was saying you could get extra long ones. So there you have a nice long one, but it's a fine thread, so it's not going to help us any. Okay, so I think we're going to have to double up. We're going to come up with a creative way of doing that. So we're going to put the first one in. And it's kind of a springy feel. That's what it's supposed to do as you're screwing them in. So. Okay, so now I've got the top of the Heli-Coil just below the surface, which is where you want to end up. I got half, 1, 1 and a half, 2, 2 and a half, 3, 3 and a half. Got 3 and a half threads down there. So I'm going to shorten one of them and put a partial Heli-Coil down in the hole. Okay, we've got a foreshortened Heli-Coil here now. This may not have been all necessary, but it makes me feel better. So. Okay, right down just below the surface. Now I'm going to take a small punch, using a little transfer punch, so I have a choice of sizes here. Yeah, that'll work. if I can get those pieces out. There's one of them, I think. Anyway, that should be our repair. We should have our hole right where we want it now, and life is good. So I'll go back and put this thing back together. Okay, well, just in case you didn't see it, there's the finished repair, and you can see the end of the Heli-Coil right there. Thanks for visiting the Old Iron Lever channel and the series on the building of the bending brake. There are a number of episodes in this series, so please check back regularly. I'll try to post them about twice a week until they're all up, assuming I can keep up with the editing. So if you like it, please give me a thumbs up. If you want to make a comment that you think I'd like to hear, well, please add that. And if you haven't subscribed, that's always welcome too. Please subscribe. Until the next episode, happy trails.